In this lesson, you will be introduced to transformations and one particular type of transformation called vertical translation. And you will be able to identify the vertex, axis of symmetry, and optimum value of a parabola given its table of values, equation, or graph before and after transformation. What is a transformation? Transformation is a rule that can be applied to an object to change its location, shape, size, or orientation. Transformations are used frequently in computer graphics. For instance, a video game character can be made to turn around and move in the opposite direction using a combination of translations and a reflection. So, a translation is a transformation in which every point of an object moves in the same direction by the same distance. So let's look at a vertical translation that is applied to our original parabola. So, this is the equation for the parent parabola. This is the table of values. You know how to do this one. And now we can quickly plot that parabola on the graph using a table of values or using a step pattern. I'm going to use the step pattern. So this is my vertex. It's going to be 1, 1. Then I go 1, 3, and 1, 5. And I think it's the same thing on the other side. So I can, of course, it's right here, and then it's right here, and then 3 units right here. Okay, so I use the same pattern, and now I am going to try to draw a nice parabola. Okay, so this is, of course, my original parabola. All right, now I'm going to try to plot a quadratic function with this equation. So y equal x squared plus 3. So I will fill out the table first. So it's going to be -2 squared plus 3 gives me 7. -1 squared plus 3 gives me 4. And then 0 squared plus 3 gives me 3. 1 to the power of 2 plus 3 is 4. 2 to the power of 2 plus 3 gives me 7. And 3 to the power of 3. 2 plus 3 is equal 12. All right. Now I would like you to notice what happened to the x-coordinates when we moved from this equation to this one. As you can see it, there's no change in x-coordinates. But let's see what happened to y-coordinates. If you compare them, you can see that they've changed by 3 units. And 3 units up. All of them went 3 units up. Let's see what it would look like on the graph. So we'll use the table of values. And it was -2 and 7. So it's here. Then there's -1 and 4, which is here. 0 and 3. 1 and 4. 2 and 7. And 3 and 12, we ran out of room. So now I'm going to connect these points. And this is my new parabola that, of course, I can extend it and it will go up there. All right, so let's compare these graphs. So as you can see it, everything got shifted 3 units up. Every single point went 3 units up. So that's called vertical translation. Okay, so in general, the equation will be y is equal x squared plus k. Okay, and let's see, let's compare the vertices here. The vertex over here is 0, 0. Over here, the vertex is 0, 3. Okay, and we can see it. It has switched. So in general, the vertex will be at 0 and k. Because as we can see it, this k value corresponds to this 3. and this it's positive, so therefore k over here is equal to positive 3. All right, and therefore the vertex is at 0, 3. Okay. Well, we can also quickly compare other geometric properties of this parabola after vertical translation was applied. So vertex has changed. Optimum value has also changed. Now it's 3 instead of 0. It's still a minimum value. What has not changed is the axis of symmetry stays at the same place. It's x equal to 0. And another thing that changed was x-intercepts. Original parabola had only one x-intercept at 0. New parabola, after the translation, vertical translation, now has no x-intercepts, no zeros. All right. All right, let's look at another example. Y equal x squared minus 2. But this time, instead of using table of values, I will use the step pattern that you've learned before. And it will apply it to our parabola. So it's going to be 1, 1, 1, 3, and 1, 5, right? So in order to apply the step pattern, I have to first locate a vertex of that parabola. So if we look over here, and I know that in general, vertex is 0, k, I need to find out what k value is. Looking at the equation, I can see that the k value is equal to -2. Therefore, the vertex will be at 0, -2. And this is my starting point. So I will go to my graph, locate the vertex, it's at 0, -2, and then I'm going to use the step pattern. 1, 1, 1, 3, 1, 1, 2, 3, 4, 5, and so on. And I will do the same thing on this side. 1, 1, 1, 3, and 1, 5. Okay, and then you join the points. You're drawing a nice curve at the bottom. And of course, there will be no maximum because this parabola opens up. And now we can see the vertex is -2. Axis of symmetry still stays at x equal to 0. And then we see that it also has 2 x-intercepts. I cannot readily read them due to the way I drew it, but also they probably don't fall right on the whole unit. So therefore, I would have to solve a quadratic equation for this parabola in order to establish exactly where those roots are. Okay, last thing to do is to be able to write an equation for the quadratic function after the vertical translation was applied. So we will do that looking at the graph. So if you can see this graph, I need to write the equation. I know that equation in general is y is equal x squared plus k. So therefore, I need to establish what k value is. Well, I also know that vertex is always at 0k. So therefore, I'm going to go to the vertex and read from the graph. According to the graph, the vertex is 0. The vertex is 0 and -1. Therefore, k value is -1. Therefore, my equation will be y equal x squared minus 1. Okay, let's fill out the rest of those geometric properties for this parabola. Direction of opening, of course, is up. Zeros, I can clearly read them from this graph. It's -1 and 1. Axis of symmetry is x equal to 0. So as we can see, axis of symmetry does not change after application of vertical translation. Optimum value is minimum at y equal -1. I mean, y is equal to -1. And we can also read another point of interception, y-intercept, and it also happens to be -1. This is where the vertex falls, right? And intersects y-axis only once. All right, so in general, in conclusion, a parabola moves up when k value is positive, and a parabola moves down when k value is negative, and the vertex at this point will be established at 0k for vertex. Okay, we will discuss other transformations in the following classes, so please stay tuned.